It's a way of studying the origins of the universe, to try to isolate what some people call the God particle. Research.
God particle?
Yeah, the God particle. That name sounds insanely dramatic. In physics, though, it refers to one of the most important particles in the entire universe. A particle that might explain why the universe even looks the way it does today.
The thing without which we could not exist.
You're talking about the moment of creation.
Yes.
But here's the weird part. According to modern physics, matter shouldn't exist at all. The universe should have remained a massive ocean of energy, perfectly smooth, with no structure at all. No atoms, no stars, no planets. Even we shouldn't have formed in the first place. But clearly, that's not the universe we live in. Matter clearly exists. And that raises a very strange question. Why is the universe actually filled with matter? If theory says matter shouldn't exist, why does it exist at all? And what exactly is the God particle? Is it really some kind of fragment of God? Well, in this video, we're going to explore that question. So, let's talk about it. Back in school, we were taught that everything in the universe is made from atoms. And we were also told that inside every atom, there are three particles: protons, neutrons, and electrons. These particles are usually described as the most fundamental building blocks of everything in the world. That's the basic explanation most of us learned in school. But there's a pretty big problem. Why? Because the most fundamental thing in the universe isn't particles at all. It's fields.
And if you believe that these particles are the fundamental building blocks of the universe, but it's simply not true. It's a lie.
According to quantum field theory, the entire universe is completely filled with fields. These fields are called quantum fields. There is literally no place where a quantum field doesn't exist. Even empty space isn't truly empty. Whether it's a vacuum or the place where you're sitting right now, everything is filled with them. And the crazy part is that according to quantum field theory, the idea we've had all this time about particles is actually wrong. What we call a particle doesn't actually exist at all.
In fact, the very best theories we have of physics don't rely on particles at all.
And you say to yourself, well, but things like this table are made of atoms, and atoms have electrons and so forth in them, and the electrons are particles, right? There are particles in the world. No, there aren't. That's the secret that we physicists have never told you, but here I am, I'm going to tell you right now.
What we call a particle isn't actually a tiny standalone object. Everything we consider particles is really just small vibrations in a quantum field. Imagine the quantum field as an ocean that fills the entire universe. Then particles are just the waves that appear on the surface of that ocean. Or you could picture it like a bump forming on the surface of skin. A particle is not a separate object, just a disturbance on the surface.
The best theories we have tell us that the fundamental building blocks of nature are not particles, but something much more nebulous and abstract, which are spread throughout the entire universe, and we call them fields.
So yeah, that's basically what quantum field theory says. Sounds kind of crazy, right? But just wait till you hear the even crazier part. If it's true that particles are just vibrations of quantum fields, then they shouldn't have mass at all. And if a particle has no mass, it can't stay still. It would always move at the speed of light. And this is where the problem starts to appear. Because if particles are always moving at the speed of light, atoms should never be able to form. And if atoms never form, there would be no galaxies, no planets, and we wouldn't exist either. The entire universe should just be filled with vibrating fields with no matter at all. This theory can really mess with your mind at first, but as strange as it sounds, it actually helped physicists explain many of the phenomena we observe in the universe. But let's pause here for a moment. If particles are not supposed to have mass, and atoms shouldn't even be able to form, then why is the world around us filled with matter? Our bodies have shape. We can sit on a sofa, can lie in bed, watching TV, or even watch YouTube on our phones. Doesn't all of that contradict what quantum field theory just told us? And the answer is yes. All of that is a contradiction. And this contradiction left scientists scratching their heads for years, and it's at this point that a new idea began to emerge. An idea about the existence of a particle that might explain all of those contradictions. And today, that particle is what we know as the God particle. But we need to clear something up first. The name God particle isn't actually its scientific name. Physicists themselves call it the Higgs boson.
What has been termed as the Higgs boson.
Right.
So explain the Higgs and the boson, both.
Okay, we're celebrating the fact that we have found a new particle.
The nickname God particle actually came from a book written by the American physicist Leon Lederman. Originally, Lederman even referred to it as the goddamn particle. The name goddamn particle captured just how important this particle was to physics, while at the same time being almost impossible to detect. But for publishing reasons, the phrase goddamn particle was eventually shortened to simply the God particle. And since then, that name stuck in the media and became popular all around the world.
We got word today that scientists believe they have now confirmed the discovery of the so-called God particle.
Researchers tonight say they think they have finally discovered the so-called God particle.
God particle.
God particle.
Some people call it the God particle. Research.
Particle?
The idea behind the God particle goes back to 1964, when a scientist named Peter Higgs proposed a hypothesis about the existence of another field that fills the entire universe. This field is now known as the Higgs field. According to this hypothesis, the Higgs field is responsible for the existence of mass in the universe. Without the Higgs field, every particle in the universe would behave the same way, and the universe would have no structure at all. To understand how this works, we need to look at the universe from the perspective of modern physics.
So what is the God particle and just what does it do? Well, in one sense, it is the missing link to this massive equation. This is the standard model for particle physics, and this is our understanding of how the universe works.
As we discussed earlier, in modern physics, the most fundamental things in the universe are not particles, but fields. There are many kinds of fields filling all of space. There's the electron field, the quark field, the photon field, and also the Higgs field. You can imagine it like a gigantic sandwich, where all of these fields are layered on top of each other, filling the entire universe. Each of these fields is constantly vibrating, and when a field vibrates, that vibration appears as a particle. And the same thing happens with the Higgs field. If the Higgs field vibrates, that vibration appears as a particle. This particle is what we know as the Higgs boson, or the God particle. Other particles that originally had no mass and could move freely at the speed of light begin to interact with the Higgs field. And as they interact with this field, it's almost as if they are being slowed down or resisted. That resistance is what we experience as mass. But not all particles interact with the Higgs field in the same way. Some particles don't interact with it at all, which means they remain massless. A good example is the photon, the particle of light. But other particles interact much more strongly with the Higgs field, which makes them heavier. These become particles like protons, electrons, and neutrons. Those particles then combine to form atoms, which eventually form the matter we see in the universe today. So once again, without the Higgs field, all particles would behave the same way. There would be no atoms, no planets, and the universe would have no structure at all. So maybe the nickname the God particle actually makes sense after all, right?
What we call it isn't important. It's what gives all matter mass, the thing without which we could not exist.
You're talking about the moment of creation.
Yes.
In theory, the idea of the Higgs field and the God particle was something physicists could accept, but proving that it actually exists, that turned out to be a nightmare. To prove the theory of Higgs field and the God particle, scientists had to build a laboratory with a gigantic machine about 27 kilometers long, costing nearly $9 billion, involving more than 10,000 scientists from around the world, and taking over a decade to build, all just to prove that this particle exists. This laboratory is called CERN. We actually talked about CERN in a previous video about antimatter. But in short, inside this enormous machine, protons are accelerated to nearly the speed of light and then smashed into each other with enormous energy. The goal is simple: to recreate the extreme conditions that can produce extremely rare particles, including the God particle. But guys, Even after building a machine that expensive, that massive, and that advanced, finding the Higgs particle was still far from easy. Since 2008, scientists had to perform billions of proton collisions inside this machine, hoping that one of those collisions would produce the particle they were looking for. And finally, on July 4, 2012, scientists from all around the world gathered at CERN headquarters in Geneva, Switzerland. The conference room was packed. Physicists, researchers, and media from many different countries came to witness an announcement that might become one of the most important moments in the history of modern physics. And when the results of the analysis were finally revealed, the scientific world erupted. Scientists at the Large Hadron Collider had discovered a new particle with a mass of about 125 giga-electron volts. A particle whose properties matched the predictions of the Higgs boson almost perfectly. Which means, after nearly half a century of existing only as a theory, the goddamn particle had finally been discovered.
As a layman, I would now say, I think we have it.
Well, I would like to add my congratulations to everybody involved in this tremendous achievement. For me, it's really an incredible thing that it's happened in my lifetime. It's taken...
This discovery wasn't just about finding a new particle. It was proof that an idea proposed decades earlier was actually correct. That empty space in the universe isn't really empty. It's filled with something we cannot see, but something that determines whether particles have mass or not. Something that ultimately allows atoms to exist. Something that allows stars, planets, and the entire structure of the universe to form. But even though the God particle, or the Higgs boson, was finally discovered at CERN, the discovery actually opened up even more questions. What exactly is the true nature of the Higgs field? Is there only one Higgs field in the universe? Or could there be other particles that we still haven't discovered? And maybe that's the most fascinating part of science. Every answer only leads to even bigger questions. Because in the end, the deeper we explore the universe, the stranger it seems to become.